Okay guys, remember for last time, okay, we discussed the formation of ions, okay, especially for sodium ion and chloride ion, okay. So again, let me remind you again, okay, when sodium atom and chlorine atom, okay, react with each other, and you can see that the electronic arrangement for sodium is 2h1, and to attain the octet structure for sodium, it will lose the electron, okay. You will lose this electron, and this electron will be transferred to the chlorine atom, okay, because chlorine atom is need one more electron, okay. Need one more electron for the chlorine atom to attain an octet structure. And after that, okay, both sodium now become iron, okay, and chloride, okay, become iron. I mean chlorine become iron, it becomes chloride ion. Both sodium and chlorine now become chloride, okay. They attain octet structure. So you have sodium ion with a positive charge, okay, and a chloride ion with negative charge. Again, why sodium ion must be positive charge and positive 1, okay, to be specific? Because for the sodium, you have 11 protons, but you have 10 electrons, okay. You have 11 proton, 10 electron, so you have 1 positive, okay, and this positive is indicated here. And for chlorine, okay, now become chloride. Chlorine add 1 more electron to become chloride, okay. The number of protons will not change, it is still 17, but the number of electrons is now 18, so the overall charge is -1. It is indicated here. So the formation of sodium chloride can be illustrated here. Remember guys, okay, one is positive charge, one is negative charge, so you expect they will attract each other, and this is how sodium chloride is formed, okay. So this is what I talked about last time. Of course, you don't need to draw this one exam, you just need to draw the outermost shell electrons, and you don't need to draw the cation ion, okay. For sodium ion or magnesium ion, aluminium ion, you don't need to draw the electrons, because for the outermost electron shell, I mean it contains no electron, because the original electrons will be transferred to the anion, okay. So for cation ion, for anion, remember to indicate there are 2 different types, okay. I mean the cross represents the electrons originally in chlorine atom, okay. But this one, okay, I use a dot, it represents this electron is originally from sodium atom, but now sodium lose 1 electron to become sodium ion, and chlorine receive or gain 1 electron to become chloride ion, okay. So this is sodium chloride, and this is what you need to draw in exam. We call it electron diagram, okay. So next one guys, we consider magnesium, okay, and sulfur, okay. When magnesium and sulfur react with each other, you know the easiest way for magnesium to attain an octet structure is to remove these 2 electrons, okay. And after remove or losing these 2 electrons, it will become magnesium ion with a charge 2+. Why 2+? Because the number of protons will not change, it's still 12, but the number of electrons, because you lose 2 electrons, so it becomes 10 only. You have 12 positive and 10 negative, so the overall charge is 2+. On the other hand, okay, you have sulfur atom, atomic number 16. So if it is a sulfur atom, you have 16 electron. But you know that, okay, every atom wants to attain octet structure. So sulfur atom need 2 more electrons to attain an octet structure. After the receiving 2 electrons, maybe from magnesium, okay, the electronic arrangement become 288. It is the sulfide ion. Okay, with a charge 2 negative, 2 minus. Why 2 minus? Because the number of protons will not change, still 16, but you receive 2 more electrons. So the number of electrons now for a sulfide ion, it is 18. You have 16 positive and 18 negative, so the overall charge is 2 minus. Okay, so this is the formation of sodium sulfide. Okay, and this is what you need to draw in exam. The chemical formula is still MgS, more or less the same with NaCl. More or less the same with NaCl. Okay, the naming magnesium sulfide. Always name the cation first and then the anion. Remember, guys. Okay, it is formed by magnesium ion and sulfide ion. So you call it magnesium sulfide, okay? But we don't need to indicate the magnesium ion, sulfide ion, because the two ions are opposite in charge, equal in magnitude. 一樣都係大二，但係一個係二正，一個係二負，okay? Opposite in charge but same magnitude. So you just call it magnesium sulfide. This is why we call it magnesium sulfide, but not magnesium sulfur, okay? Because they are not atoms, they are ions. So this is for magnesium reacting with sulfur. Next, we consider aluminium and phosphorus, okay? You don't know anything about group 3 and group 5, but I tell you guys, okay? Aluminium, electronic arrangement 2x3, okay? Atomic number 13. And phosphorus, group 5, okay? Group 5 elements, atomic number 15. For aluminium to attain octet structure, it is best for aluminium to lose the 3 electrons, okay? Lose the 3 electrons. And for phosphorus, okay, not for sulfur. For phosphorus to attain octet structure, phosphorus need 3 more electrons, okay? So if aluminium is reacting with phosphorus, these 3 electrons can be completely transferred to phosphorus, so that both of them attain octet structure. Again, for aluminium, guys, okay, the number of protons is 13, but aluminium lose 3 electrons. So now, after the formation of aluminium ion, you will have only 10 electrons. You have 13 positive, but 10 negative. So the overall charge is 3 plus, not plus 3, okay? And for phosphorus, originally you have 15 proton, 15 electron, but now in order to attain octet structure, phosphorus gain 3 more electrons. So the number of electrons now becomes 18. You have 15 positive and 18 negative. So the overall charge is 3 minus. It's 3 minus. Okay, so girls, of course you expect they have charge, so they will attract each other because one is positive, one is negative. So aluminium phosphide will be formed. Aluminium phosphide with the chemical formula AlP. AlP. Okay, so Al3 plus and phosphorus. Guys, remember, use 2 different notation, normally a cross and a dot, okay, to indicate 2 different types of electron. Of course, electrons are the same type, but they are from a different position, okay? These 5 I circled originally from phosphorus atom, but this one, these 3, originally it is from the aluminium atom. But now, aluminium lose 3 electrons to become aluminium ion, and phosphorus gain 3 electrons to become phosphide ion. And both of them is a win-win situation because both of them attain octet structure. And because they have charge, they will attract each other, and formation of a compound, aluminium phosphide. So this is the basics for ionic bond. Next, guys, we talk about the general situation. Actually, it is in the book. Okay, so I just used the book. Guys, okay, we can consider the periodic table. Of course, this is a simplified version. Still remember, for group 1 elements, all group 1 elements has 1 outermost shell electron. All group 2 elements, okay, have 2 outermost shell electron. So guys, okay, for group 1 element, they have common characteristics, okay. They all, I mean, in order for group 1 element to attain octet structure, okay, they all need to lose 1 electron to attain octet structure. 大家 group 1嘅都係最出邊電子最出邊有一粒嘅電子啦，即係最出邊嗰層嘅電子有一粒。咁要有 octet structure 最容易嘅方法就係甩咗嗰一粒嘅電子，所以大家都係一個 plus。咁同樣地 for group 2 elements, they all have 2 outermost shell electrons. So the easiest way for all the group 2 elements to become octet, of course, is losing the 2 electrons. So after losing the 2 electrons, all of them will become 2 plus, okay? All of them have the 2 plus charge, okay? You can see all group 1, group 2 elements, okay? I mean, they have the same charge. For group 1 they have 1 positive, okay. For group 2 they have 2 plus, okay, 1 plus and 2 plus. So you expect for group 3 3 plus. But for group 7 guys, okay, for all the group 7 elements, they need 1 more electron, okay, because they have 7 outermost shell electrons, and they need just one more to attain octet structure. So you expect, guys, all of the group 7 elements, okay, after the formation of the ion, it will carry a negative charge, okay. All of them will have a negative charge because all of them just need 1 more for the atom, okay. Fluorine atom, chlorine atom, bromine atom, iodine atom just need 1 more electron, and then they will become octet, and then they will have the octet structure, and they will become chemically inert. So fluoride, chloride, bromide, and iodide. And for group 6, okay, oxygen need 2 more, okay, sulfur need 2 more, okay, electrons to become chemically inert, okay. So they will gain 2 electrons, and oxide, sulfide. And for group 5, they need 3 more. Nitrogen becomes nitride ion, okay. Nitrogen atom becomes nitride ion, and phosphorus atom becomes phosphide ion. The common characteristic is that all the cations retain the name, but all the anions, guys, okay, they will end with IDE. It is easy to remember group 7 because you have learned it. Group 6, I think no problem, but just I think for group 5, okay, especially for the word phosphide, this is quite difficult for you to spell. So guys, you can see for metals, generally they will form cation. Wait, I don't think positive ion is a good word, okay. I just call it cations. Cations will be formed with metals, okay, from the atoms of metals. And for the non-metals, the atoms, they will form anion. So cations for the atoms of metals, and anions for the atoms of non-metals.